Well, hello and welcome to this presentation. What I wanted to cover was to give an overview of NASA missions and media and how we can be using that as a STEM teaching tool. And I'll get into STEM, science, technology, engineering, mathematics, and medicine. And I'm going to be using these two movies, which some of you may have seen. And if not, I highly recommend that you do view them. I think it'll help to make the material a little bit clearer as we go through this. But we're going to be thinking about both the movie content and, when possible, the actual people that the movie portrays. And you'll see what I mean as I get into this. So let's first of all, I'll give you an outline of the material that we're going to cover. I'll give an overview and a little bit more than what I'm bringing here, but so let's just focus on the outline. So first we'll have an overview. We'll get into the NASA missions in these two different movies, Hidden Figures and the Martian. Both, relatively speaking, are recently produced movies and have had a good um, showing in the movie theaters and all of the various ways that you can get your video content. And so for Hidden Figures, I'm going to talk about three different characters: Katherine Johnson, Mary Jackson, and Dorothy Vaughn, and give a little background on them, how they were involved in NASA missions, and then start to think about how we can apply that towards general STEM teaching. And the other movie, the Martian, it's a notional individual, Mark Watney, and so I'm just going to be referring to him as with this name and not be referring to the actual actors that are portrayed here in the two posters for the movie. So after that introduction, and we'll get a chance to get into a little bit of a technical detail, we'll then start to be thinking about how can we use this for STEM purposes. And so first, I'll have a little bit of material here focusing on the life lessons that we can be getting from these individuals, and I'll be highlighting three different areas. Then we'll get into the pedagogy for teachers. We'll be talking about 10 specific STEM topics, four general core topics, and then six that are getting into specific areas of engineering and computer disciplines. And finally, we'll have a conclusion, and I'll also have one other chart that will give you a sense of the references that I'm using. So we want to be thinking about the inspirational value of media that captures NASA missions and the accomplishments in science, technology, engineering, math, and medicine, STEM, and what we can be doing using that in terms of educational purposes. The goal is to encourage students to learn science, technology, engineering, and mathematics concepts. And we know that this is something that is challenging. We want to provide evidence of its value and how it can radically change their perspective when you see people that are actually doing what you hope to be accomplishing in the future. We'll get a chance to showcase critical points showing individuals' breakthroughs from learning STEM skills and drawing upon them in critical life moments. And so we'll be talking about a handful of specific situations that come up in Hidden Figures and the Martian. We want to reflect on the lives of the three historical Black women at NASA: Katherine Johnson, Dorothy Vaughn, and Mary Jackson. And we'll also be thinking about a realistic future project that challenged the NASA crewed mission to Mars, and we'll be focusing on from the point of view of thinking of what Mark Watney portrayed in that movie. We want to be discussing the historical accounts of the NASA projects and people. And so we're going to be seeing how this mission to Mars leveraged real projects. And so we'll be also highlighting the STEM skills and their applications. And I'll have a couple of tables that may help you to be aware of those. And finally, unpack the STEM skills of these individuals, showing the skills they use to solve their challenges. Okay, let's first get into Hidden Figures. And so these are the three individuals that I'll have a handful of charts on each to introduce them, both their real background, since these are historical figures, as well as the things that are portrayed in the movie. First of all, Katherine Johnson, she was a gifted NASA mathematician and aerospace technologist. They use this term computer for individuals, and we'll be seeing that term come up a couple times here. She supported NASA's first human crewed space program and its Space Task Group, what they portrayed in the movie. And one of the things that she did was did the trajectory analysis for Alan Shepard's Mercury mission that occurred May 1961 with Freedom 7, and this was America's first human space flight. And so this is something that's prominent in the movie. She did a variety of different reports, but her very first one that she co-authored was determination of an azimuth angle at burnout for placing a satellite over a selected Earth position. So that's just an example of her capability. She was a member and lay leader in her church. That was an important part of her life. And she was also the Medal of Freedom recipient in 2015. And the illustration I'm showing here is when she actually received the Medal of Freedom. So what did she actually get involved with? So let's think about the Mercury mission, that you need to be sending up a rocket with a human being in it to go to be launched, to then get into an orbit and then calculate the reentry. And so this is trying to give you a sense of that. So gravity is the things that keep things on Earth. There's a rotation of the Earth. And so if you start launching things, this is another force that is exerting itself on that rocket, that spacecraft, that human-rated system. And then, this thrust has to be greater than gravity, and we want it to be in a controlled fashion. So basically, we're doing a launch from Earth, and this is a parabolic nature, and they talk about this in the movie. And so you start from going from a parabolic to an elliptical, and a circle is an example of an ellipse. And it's most likely an orbit is not going to be perfectly circular. So that's the first part, is getting it launched, putting it into a stable orbit, and then at the right point, cause a re-entry event, go back to a parabolic and have it splash down, and you're able to find out where that individual is on the Earth. So here's the first of 4 tables that I'll be showing. And so for Katherine Johnson, a NASA mission analyst, she was very adept at both math and physics. And so she was called, the term that they used at that time was, a computer was an individual. We think of computer as a piece of hardware that you buy. And so she was very adept in math. And so she had to be aware of both math and physics. And so the kinematics of motion and forces, that would be something that she'd have to be thinking about. She'd have to be thinking of math for the space launch, for the orbital insertion, and the re-entry and landing. All of these things were things that she did. And they had this concept that they talk about, the go, no-go decision right before launch, that you double check all of your numbers, make sure that everything looks good, you know exactly how it's going to work, you know where they're going to be picking up the astronaut when they come back to Earth. And finally, another extremely important thing, and I'll come back to this as one of the STEM skills, is to be thinking about collaboration, coordination, teamwork. All of those are things that Katherine Johnson had to demonstrate. So that's a first. The second is Mary Jackson. She was a NASA aerospace engineer, the first NASA Black engineer. And so she had a whole bunch of firsts. And the situation was that the way that they had their criteria for a person at NASA to become qualified and have the appointment as an aerospace engineer, you'd have to have a master's degree. And the courses were at a white high school that she would have to be taking these courses. And so she had to petition, go to court, and win the right to be able to go to a white school and thus be able to get her classes, get awarded a master's degree from the University of Virginia, and really launch her career in the direction that she wanted to do. So she did a variety of reports. Her first one that she did was the effects of the nose angle and Mach number on transitions on cones at supersonic speeds. And I'll talk about that in a minute when I have the next chart up, and it may make a little bit more sense. She also had an open door policy in her career that for young Langley recruits. Langley is one of the NASA centers in Southern Virginia. She would try to help them to get acclimated to the town and to a new career. And she really was trying to give back. And so for the Mercury capsule, what were some of the aerospace, the aerodynamics and thermodynamics things that she had to start to get familiar with? And so first, the aerodynamics, you want to have things go smoothly up into orbit. And so to have things in a smooth fashion, I'm just showing the capsule here, but there actually would be for launch, there would be other things on top of this. But I'm just trying to notionally have this idea, the aerodynamics that you would want to have. You don't want to have anything being exposed as smooth as possible to try and make this launch be aerodynamically the best it can be. So this would be trying to give you a sense of notionally the things that would be an issue for launch. And then for re-entry, having the heat shield. There needs to be a lot of thought put into the thermodynamics that you need to have survival going through the atmosphere and to keep the astronauts at a temperature that's viable and then eventually land where they're meant to land. So these are the types of engineering types of challenges that needed to be faced. So in a table format, like I showed with Katherine Johnson, let's think about these things. So she still was this group, these individuals that were classified as computers, and she was well versed in math and physics concepts, and she did make this transition to become a successful engineer. She had on-the-job training. She got her master's. All of these things were things that propelled her to be able to succeed in that front. She had to be thinking about thermodynamics. And so you can be thinking about the Mercury capsule heat shield for aerodynamics, the Mercury capsule surfaces to make them as smooth as possible so it's not going to be heating up, and also to take the least amount of force to get it into orbit. And she definitely did a lot in the aerospace engineering arena, orbital analysis, doing space mission calculations. These are things that she would be well versed with. And she had to be doing with a lot of collaboration. She was working with the NASA engineering team. She had really good people skills. She also had to go to court and petition so that she could actually successfully meet all the requirements to become an aerospace engineer at NASA. And she did all of those things. Okay, the third person from Hidden Figures is Dorothy Vaughn. She is portrayed in the movie and actually in real life was a NASA manager. This was the first of two major roles that she had. She developed a handbook for algebraic methods for calculating machines, and so acting as a human computer, you can see how that would be of use. But she also had the foresight to know that computers, as we think of them now, were getting to be more and more prominent. It was just at the very beginning when she saw this. And so she taught herself Fortran and then taught others the same thing. She was also a dedicated member of her church, and so having that network and that spiritual part of her life was important. She was the first Black manager in what was the West Computing Group, and so eventually that became a permanent role. She contributed to the Scout Launch Vehicle program aimed at placing small satellites in Earth's orbit. And so small sats, CubeSats, those are still things that are a viable part of what NASA is doing as part of their mission. Various ways of deploying space assets for remote sensing and other science areas. She had Vinnie first. She was a first woman manager as well as a Black individual taking those roles, a programmer, and she led her group from acting as human computers to doing it the way that we're familiar with now, computer programmers who also were doing the results analysis of the material that they had found. And so this is just a illustration of the kind of things that she did, and so she helped this transition, this change of paradigm from human computers being individuals to humans that are using electronic computers. And so predates probably what most people are familiar with, but at the very beginning of computing, you'd had to have these punch cards. And so this is just a simple notional program in Fortran of how you can be doing something that would be relevant, say, for things that Dorothy Vaughn or some of the other folks that are trying to do that programming would be working with. And so they actually had this IBM 7090 data processing system, DPS, that they had to do the hardware troubleshooting and configuration. And Dorothy Vaughn demonstrated that she had the skills to do that in the movie. And she also had to be on the software development. So she had to write code. So computer science and hardware troubleshooting, computer engineering, these are two things that she was involved with. And so this is a table trying to summarize some of those things. She acted as a human computer, so she had to have these basic STEM skills, largely focused on math. She was a supervisor, and so it was informal at the very beginning, as was portrayed in the movie. And so here is when she started to showcase management and leadership skills, and having to do this coordination with the complicated way that things were set up at NASA. She learns Fortran. So this is an example of a high-level programming language, and so she's demonstrating computer science skills. She was familiar with computer architecture. She had to learn the IBM 7090 architecture to be figuring out how to make it work. Something the way that they portrayed it in the movie, it was even stumping the IBM engineers, and she was able to come in and really help them get it to work. She was not only able to learn computer science, computer engineering, she was able to teach these skills. And so this was something where she was able to share. And so we get into this coordination, collaboration, teamwork. These were all the things that Dorothy Vaughn also had to demonstrate. Okay, of course, the movie goes into this in a lot more detail, but now let me focus on the second movie, thinking about the Martian. And Mark Watney is the key individual that we get a chance to be thinking about. Of course, this is a notional individual, so I'm not going to have like a summary bio of this individual. But the things that they did in this, it's a future Mars mission, but they were leveraging predecessor missions and current capabilities. And so you can see, even though it's notional in the future, we're working our way towards this. And so you can see that it's really tied in some missions. And so I'm going to focus on some of those missions and show how that was a nice relationship that they built upon. First of all, they talked about the Pathfinder, which was a demonstration, low-cost Mars lander and rover. And so this is trying to give you an illustration of what the Mars lander looked like. I'm going to have a couple of notional diagrams, cartoons that will be getting into the guts of thinking about this. And they also had this deep space network where they would have these large dishes on various places around the Earth, and so that you can continue to have coverage of communication going back and forth between Earth and Mars. Okay, I'm not going to go over all of these in terms of some of the following tables. I'll have three charts that I'll be focusing on, but let me just quickly go through this. And so if you're going to be an astronaut, you have to learn how everything works on the mission. You're going to be a mission specialist in your particular area. Mark Watney was an expert in biology and botany, but he would still have to be able to navigate through everything else that was available. We see that demonstrated. And so as a result, he had this ability to be doing this top-down engineering of seeing things at a high level. He may not know the details of why things work, but he knows how all these systems work. And so he was able to demonstrate skills and utilize skills as a systems engineer and able to plan various types of solutions. In terms of botany, there was a couple of things that needed to actually take place if he was to successfully be able to grow food. He needs to have something that would grow, and it turns out they had planned for Thanksgiving, and so they had potatoes. He was able to plant sprouts that were what would eventually become a major food source for him for his extended stay on Mars. But he also had to be focusing on the soil generation. So for the potato sprouts, the thing that I'm going to be focusing on is how he was able to generate water, which was something that was in little supply. And then something I won't focus on in much detail, but just in this table, thinking about how did he condition the soil so that you could actually grow things. You have the sprouts, and then here is the chemistry portion of the water that's going to be key for actually growing the crops. All of these things had to come in union to make this happen. He then wanted to reestablish communication back to Earth, let them know that he was there, and so he had some basic communication capability that he was able to do with that front. He was also had to think about computer architectures. And so he had to think of how he was going to take parts of Pathfinder, do some diagnosis, get it up and running. And eventually, with the help of JPL and NASA as a whole, he had to start to do some programming, fixing some of the code to turn it into a two-way texting app. And so that is something that they also portrayed in the movie. There's a couple other things that I won't focus on here, but other than this table, he had to be retrofitting the rover. Part of this was for this communication system, but also to be trying to get from where he was at his habitat to another place where there is a MAV, a Mars ascent vehicle, that he needed to reduce the mass and prepare it for a rendezvous with the rescue mission that eventually is showcased in the movie. So a lot of things that are here, but I wanted to give you a little bit of a sense, and you can be pausing this video and spending a little bit more time on this table if you would like. So here are the first of three charts that we'll be getting into some of these things. So first of all, he had these types of materials. He had hydrazine, so this would be the fuel that he would have for that was available. He also had oxygen, and what he wanted to get was water. And so with chemical engineering, he can know that he can have a chemical reaction. If he can have heat, that he could have this hydrazine plus the oxygen that was available in the habitat and heat, he could turn this into nitrogen, which wasn't something he needed, but he needed to get a lot of water to have the amount of water that would be needed to water his crops. So that's the first example of something of a challenge that he had to come up with and solve. The next two charts are going to be thinking about communication. And so this gets into some electrical engineering, computer engineering types of things here. And there's something called an ASCII table. There's a couple other terms that are used, but I'm just going to be using it as ASCII. And so basically you have two hexadecimal digits. And so a hexadecimal digit goes from 0 to F. And so you can see this laid out here. So it's base 16 is what a hexadecimal system is. And by if you were to convey two hexadecimal digits, you could then have any number of letters, lowercase, uppercase, punctuation, numbers, all of that. And so what he devised, and you'll see a better picture of this in the next chart, on the Pathfinder, it actually had this one camera. And what he was going to be using that as this way that he could have it that he's going to have that if you point it in a certain direction, and he's going to have these signs with these numbers on it, 0, 1, 2, 3, all the way up to F, the folks that are trying to convey information up to Mark Watney on Mars, they can actually say, okay, here is the first. It would be like 4 and then 1. And if I look in this table, 4, 1, that would be conveying the letter capital A. So this was a basic form of communication that started out at the very beginning. He was just doing yes, no. And so we just have enough pointing from one to another. He could ask a question and say, and start with yes, no. Then he came up with this ASCII table and a way of using resources to form a basic way of having communication. And then here is the phase 2, where, okay, now we have this communication. We're going to get it so we don't have to be using this way of using the IMP camera, but we're going to reprogram this RISC 6000. And so this is a central processing unit. Here you can be seen in the MAV, what was the imager for Mars Pathfinder, IMP. And so you're going to be using the deep space network to communicating here. And then from there, with this reprogramming of the CPU and the Pathfinder, using some other resources that would be in the rover and the habitat, with the help working collaboratively with NASA back on Earth, he was able to come up with a elegant way of getting a text way of communicating back and forth, and so was able to have regular communication. Okay, so that's the first section. Now I'm just going to have a handful of charts thinking about what about the life lessons that we can be learning from the NASA missions and the people involved. And so I'm just going to be focusing on a few. But if we think from a teacher's point of view, this is what we're trying to pass on to the next generations. What are the things that they need to be doing? And I'll have charts on each of these. And so we want to try and motivate students to pursue the STEM education, and using the examples that we have from these 2 NASA movies, NASA mission movies, it is actually can be something that can help. We want to encourage critical thinking and planning, and I'll have a chart that's going to get into that a little bit more, and support their paths for practical experience. So the life experiences of the 4 individuals discussed in this presentation are rich in the areas that can help instruction in the classroom. Each had significant challenges that they had to work through. It was not only hard work, but their investment in education, critical thinking, and practical experiences served them well to be ready for each step in their career and personal development. And we get a chance to see in these movies not only their technical development, but their personal development. And it is pretty amazing, these individuals and where they went. So here's the first of 3, getting into a little bit more detail, motivating students to pursue STEM education. We want to remind students that they should invest in their future. It is their life and it is too precious to waste. So I'm hoping not only teachers, but students may find this video interesting and useful. And so whoever is benefiting from this, that makes me glad. So landing a job in their chosen occupation will require demonstrating the skills sought by hiring managers and the degree showing credibility to back it up. And so those are things that we want to be thinking about. Pursue the education. We want to encourage students to work hard in school, help them find the necessary motivation by linking what they have learned with what they want to do. And that gets into helping them tailor their class assignments, course choices, trying to give them chances where they can have site missions, say going to a NASA center, be involved in tours, internships, media choices, say like these movies, and both in the teaching experience and just in general, what they would be choosing to be, what they would do in their own free time for entertainment, and what they want to do in their career, helping them start to be thinking about that. Critical thinking, this gets into system engineering. We got a chance to be seeing that mostly with Mark Watney, but even all of the other three individuals in Hidden Figures, they had a chance to be thinking of life-solving techniques. So we want to remind students to never give up. Mark Watney faced death, but overcame near impossible odds on more than one occasion. And I think that is really well portrayed in the movie. But there's also this idea of planning. Maybe some of you have heard of an individual named John Goddard, who, at the age of 15, he wrote this list of 127 goals that he wanted to accomplish in his life. And the fact of just writing those things down makes it far more likely that you're actually going to accomplish that. And so at the time of my reviewing, he completed all but 16, a total of 87% of what he had done. And this is a noble goal, not only for folks that are 15, but regardless of one's age, to be able to plan and to be able to work on getting problem-solving techniques that you could be using in your life. And then supporting students' path for practical experience. Number one is probably going to be the teacher, so that would be us. And if you're a student, I hope that you can find those supportive teachers that can be helping you. No one is an island. We need mentors and colleagues. They will help us gain the skills needed and give us a perspective that is necessary. Teachers can be a wonderful first step in helping students create their own network and propel them towards success. All four of the NASA individuals gives valuable insight into this fact, but two show how they gave back to future generations. And so Mary Jackson, so she always had this open door policy for young Langley. So just a reminder, Langley is one of the NASA centers in Southern Virginia. Recruits as they were trying to start in a new town and a new career. And at the end of The Martian, Mark Watney portraying giving back and mentoring support to others towards and helping them see that it's worth it. What's it like to be involved in space missions, and being very candid about his own experience and what he had. Next, let's talk about, well, what are the specific things that we can be teaching students? And for students, these are the things that you wanted to start to plan out your specific path. And so I'll have 4 basic STEM skills and then get into 6 specific engineering and computing disciplines. These are examples of STEM careers and ones that you could be making a choice to do. So communication, coordination, and teamwork, engineering, both general and systems, mathematics, and physics. Those would be all encompassing. And so this is not getting specific about engineering for the most part. And now we get into more specific areas: aerospace and aeronautical engineering, chemical engineering, computer science, electrical engineering, and mechanical engineering. And we'll have a slide for each one of these. And so here are the core STEM. And so we have 4 of those. No matter what the endeavor, there is a need for good communication, coordination, and teamwork skills. All 4 of these individuals we've got a chance to talk about demonstrated them. For engineering and computing, there is a need to excel in both oral and written technical communication. And so for some short vignettes, things that we've talked about, but now being more focused for each of these STEM skills. First, Mary Jackson, to reach her goal of being an aerospace engineer, Jackson must effectively communicate with the judge, who has the authority to grant her the right to take graduate engineering classes at an all-white school. As shown in the movie, Jackson researched the judge and spoke in an articulate, respectful, and convincing manner. So she did her homework. She understood who she was talking to, what was it at stake, and she got what she wanted. And so this was just an example of the kind of skills that one would like to have to succeed. Dorothy Vaughn worked within the challenging NASA organizational structure, proving her worth as a programmer and manager. This led her to permanently being assigned as a manager and transforming her programming team. She was a leader. She was the first but she brought other people with her to success. A wonderful story there. Mark Watney had to convey technical information with limited resources to get effective communication started with NASA. And you could see how that was using ASCII characters and coming up with a circle and putting stakes in the ground to start to have some basic sharing information to get that started. And so they had to have a way of using a common code, and he was trying to lay that out so NASA could be seeing that. What are the skills? Communicating with the audience in mind, having good oral and written technical communication, and being a team player. Next, well, let's think about engineering, both general and systems. An engineer is a creative, ingenious individual who finds solutions to practical problems applying physics and mathematics, formulating approaches in a structured way. Engineering analysis follows a systematic method that documents findings and generates reports that support the selection of a solution from a range of alternatives. And we saw a couple examples, Katherine Johnson and Mary Jackson, that they wrote these technical reports. And so that would give you an idea of that. And we have a couple of vignettes. First, Mark Watney showcased skills in system engineering by solving complex problems again and again. And so I've just highlighted a few, and in the table I showed, I mentioned more. Watney boosted his botanist experience through system engineering training in his NASA astronaut education to grow food. He had to integrate many disciplines and technology to form workable solutions amid limited resources on Mars. Then we have Dorothy Vaughn, who showed system engineering skills by reframing her situation. She had to identify what was coming and how she could make herself and her team valuable in the new computing paradigm. She taught herself how to program in Fortran. She also fixed the IBM 7090 DPS system, which stumped the IBM technicians the way they portrayed that in the movie. And for the skills that are part of this, the first is to think like an engineer, having the ability to do top-down system engineering, think of things in black boxes. You may not know exactly the details, how things work, but you start to relate things in a structured manner. And finally, there's a structured process for the design and evaluation that we use in decision-making. Third, we have mathematics. Mathematics is a tool commonly used in our day-to-day life. From NASA missions, as well as other multidisciplinary endeavors, mathematics can get very specialized when seeking to characterize, model, predict, design, and operate complex systems. Looking at NASA's website, it is easy to find examples of the mathematical problems they must solve. I'm going to have a reference chart at the very end. I didn't include references on all of my charts, but have them there. And so that's something that I'll also try and make available when I post this video. In terms of vignettes, Katherine Johnson is a really good example here that she had to combine two parts, the launch and reentry for this overall mission. And it boils into a variety of things. And so there was a suborbital mechanics and orbital mechanics that had to be figured out. And these were mission planning parts of space launch, orbital insertion, reentry, and landing. And so she devised a solution for the missing piece in the transition between suborbital and orbital by using Euler's numerical method of mathematics. And so this is an example of a math area that she had available to her with her mathematical understanding that she could use and go from that. So what are the skills? General mathematical understanding and having awareness of specifics. And so the specifics for this example for Katherine Johnson was Euler's numerical method of mathematics. And then finally, for the general core STEM skills, we have physics, and physics is an all-encompassing discipline ranging from small to the large, from things that are old to things that are new. It considers physical quantities from the atoms to galaxies, from the application of electrical circuits to aerodynamics. In short, physics is very much a part of the world around us, but is something the average individual does not think about very often. So in STEM, we get a chance to be thinking about this more focused. NASA missions must harness the laws of physics to accomplish their goals. Engineers must be aware of the physical laws and use them as a fundamental element for formulating designs. Katherine Johnson is a good vignette to be focusing on here. She had to know both physics and mathematics to do her NASA job. She must understand kinematics. This is an area of physics and the physics of motion. So what are the things that are leveraged here? The skills, the STEM skills, general physics understanding, and for the specific example for Katherine Johnson, the kinematics and the physics of motion. Okay, now we're going to get more specific, and we're going to be thinking about 6 different engineering and computing disciplines one at a time. First, aerospace and aeronautic engineering. Aerospace engineers explores the range of engineering from airborne platforms to space systems engineering. Aeronautical engineering explores the physics and mathematics required to make viable flight systems in the atmosphere, for example, designing the next generation of airplanes for Boeing. And so for a vignette for this, Mary Jackson, she sought to get a master's degree in aerospace engineering to secure a position where she would be on par with her peers. The immediate need at hand was figuring out how to solve the design shortfalls for the Mercury capsule. She was key in resolving the aerodynamic challenges and the thermodynamics, but I'll get into that in a little bit. So what were some of the areas related to aerospace and aeronautic engineering? Aerodynamics and orbital mechanics. Here we have chemical engineering. Chemical engineering applies physical sciences, biological sciences, and mathematical sciences to the design, development, and maintenance of chemical processes that convert raw materials into useful products. This includes fuels, fertilizers, insecticides, plastics, explosives, detergents, fragrances, flavors, electronic chip manufacture, biotechnology, and pharmaceuticals. And so quite a range there. Mark Watney knew the requirements to grow food from his botanist training. Besides generating viable soil, he knew that water was key in limited supply. He had oxygen and hydrogen. With enough chemical engineering understanding, he knows with heat, he could cause a chain reaction that creates water. And so what was the skills that are related here? Chemical reactions. And so this would be one of the things relevant for chemical engineering. For computer engineering explores the utilization of computer systems to provide control and at times automating an ever-growing number of devices. Computer engineers design and program these devices with cyber, that's the software portion, and physical, the hardware portion, elements working together. And so vignettes, we have 2. Dorothy Vaughn had to determine how to get the IBM 7090 DPS to work. This required computing engineering skills to diagnose the signals that were and where they should be going. Thus, she engaged in computer engineering, thinking in terms of a cyber physical environment that software and hardware must work together in partnership for computing to take place. Mark Watney, in a similar vein, had to get the Pathfinder hardware to work again by replacing the power supply, booting up the hardware, and getting to work with his habitat resources. So what are the skills? The STEM skills: computer architecture understanding, and hardware troubleshooting, and information system understanding. Related but different is computer science. Computer science is more on the cyber side. It's a study of computation, information, and automation. It utilizes algorithms and data structures as it explores modes of computing. Programming skills are a key endeavor in this discipline. This can include programming in a variety of languages, developing algorithms, generating data structures, working with input and out devices, troubleshooting programs, etc. And we have 2 vignettes that we can relate Dorothy Vaughn had to program the IBM 7090 DPS with Fortran. She had to translate her computing ideas into Fortran and then generate the punch cards that would run on the machine. That was the way that you inputted programs to be run, and she succeeded in her endeavor. Then Mark Watney had got his basic communication system to work. Then, with the help of NASA, he was able to update the compiled Pathfinder code. And so we're dealing with something called assembly language here to make it act like a two-way texting platform, and that was a success. So what are the skills? Programming skills, that's going to be important. And then finally, programming for specific hardware platforms. And we can see examples of that. You're doing scientific programming, analytic programming for the IBM 7090, and you have a RISC 9000 processor that's embedded in the Pathfinder. That's another type of programming. So two specific platforms that would have a different focus. Okay, we have two more. First, electrical engineering. Electrical engineering applies electricity, electronics, and electromagnetisms in a growing number of ways. It is a key enabler for the numerous electronic devices that are commonplace in modern society. There's other things that are related, and the things that Mark Watney leveraged. It also includes communications at a distance using radio frequencies, RF, and optical frequencies, which typically is thought about in terms of wavelengths. Additionally, it's engaged in many specialty areas such as microelectronics, space exploration, Internet of Things, neuromorphic computing, quantum computing, et cetera, et cetera. So Mark Watney, in terms of a vignette, knew that communicating with NASA was vital for him to survive and to plan his rescue. He had extremely limited resources and must figure out how to use them and create a basic two-way communication system. He had to go find the Pathfinder, bring it back to the habitat, and then start to configure it. So this is a key area of electrical engineering and wireless communication. He integrated old mission hardware with resources in his habitat to make this happen. Both parties must know the encoded information used. Mark Watney, as well as NASA back on Earth, he picked an easy-to-use form, and I talked about these ASCII code that allow for a more complex message than what they were using at the very beginning was yes or no. So what are the examples of skills that are used? Coding of signals. He came up with a method. That's Mark Watney, electronic communicating theory. And so that would be something that is part of what you would learn in electrical engineering, and then radio frequency communication. And so what would be the code, then transmitting it over a distance. Those are some of the challenges that come up there. Finally, our last STEM area that we'll cover is mechanical engineering. Mechanical engineering is one of the most versatile engineering disciplines. There are, in terms of numbers in education, maybe 50% or more are getting training in mechanical engineering. Many aspects of life touch an area of mechanical engineering topics. It deals with the movement of energy in a variety of systems. It considers thermal design and machine design in the development of mechanical systems such as cars, trucks, aircraft, ships, spacecraft, turbines, industrial equipment, robots, heating and cooling systems, medical equipment, etc. And so for a vignette, Mary Jackson is a great example. She had to solve both aerodynamics and thermodynamic problems for the Mercury capsule in the same design. The thermodynamics is the thing that is a main component here. She must demonstrate mechanical engineering skills to design a heat shield that is adequate to keep the astronauts safe during re-entry. What are the skills? Thermodynamics, mechanical structures, and mechanics of materials. And so those are examples of things that are relevant. Okay, well, let's just have a couple more charts to just finish this and just remind what we've got a chance to be focusing on here. This presentation explored the value of media and STEM education. It considers two movies, Hidden Figures and The Martian, that explore NASA missions and the life of 4 individuals. It shows the type coupling of 3 areas, the NASA missions and its goals. So it's the purpose behind what's going on, the context, the events in the life of the four individuals, how that where they were engaging with those missions, and finally the relationship between STEM skills and the accomplishments made. Hopefully those that are watching this video, you could see that link in a more effective way. But of course, watching these movies is going to be key, and I hope that you all take the time to do that. So this presentation first provided the NASA mission context and life context of Katherine Johnson, Mary Jackson, Dorothy Vaughn, and Mark Watney. And it tried to include enough technical details to highlight the STEM skills that are utilized and picked up in the next portions. Next, the presentation provided a life lesson sections highlighting the value of STEM education, planning, and mentoring as seen in the lives portrayed in the national missions. And so students must generate a plan to go where they are to getting the proper education to the mission showcased in the movies. And so planning is important. We're trying to get these life skills to propel them forward. And finally, the third part is provided a handbook for teachers and hopefully for students who want to relate engineering and computing STEM skills to the movie context and the lives portrayed in the two national missions focuses, and start to personalize it and make it things that you all would like to be accomplishing. So this is an eye chart, but I'll just keep it up here for a minute. So this is the references that I used. I have links here as well. And God willing, we'll have a book, and this will be one of the chapters in how we can be helping educators with media. And that's something that hopefully will be happening in the next few years. Okay, thank you all for joining me with this. Have a wonderful rest of your day.